In section 5.1, we learned to take derivatives using natural logs. In 5.2, we're going to integrate with them. Personally, I think this section might be a little bit easier and more familiar. And the reason that I say that is it just goes nicely with U subs. When I look at this problem, immediately I think, okay, this has a squared, and up here in the numerator it's first power. So when I U sub, I'm going to make U the denominator. So du would become negative 6x dx. I'll kick the 12 out. I'll give myself a negative 6. I'll divide by negative 6. That provides the du. There's the negative 6x dx that I need. Out front I have a negative 2. And it's the integral of 1 over u du. And we already know what 1 over u is when you integrate it. That's natural log of u. Because when you take the derivative of natural log, of course it's 1 over stuff. We're just going backwards. Obviously we don't want to forget our plus c. And we also want to put the 7 minus 3x squared back in. The absolute values should be on there. Once in a while I forget to put them on. If you ever notice that live, I'll give you a bonus point. But they should be on there just to signify that you have to take natural logs of positive terms only. And so that's your answer. Negative 2 natural log of 7 minus 3x squared plus c. All right, here I have tangents. That cosine squared is really a secant squared. And so I see a good u du combination. I'm going to make u tangent of 6x, causing du to be 6 secant squared 6x dx. By throwing a 6 and a 1/6 into the problem, I have the 6 secant squared 6x dx right where I want it. So that's du. The rest of it will become 1 over u. I'm going to kick the 9 out. In front will be 9/6, which reduces to 3/2. And of course, the integral of 1 over u du is natural log of u. So our answer is going to be 3/2 natural log tan of 6x plus c. And just like last problem, you should have absolute values around the tangent of 6x, just to ensure that it won't be negative because you can't take the natural log of a negative number. All right. You know what's interesting? This doesn't seem like we're doing anything really new except that we keep getting 1 over u and that turns into natural log. And that really is the only new thing. I don't know if you noticed this or not, but when I taught you to integrate in chapter 4, I put in almost every possible exponent you could think of. You know, x to the 4th. Heck, I would even make it like 4.1 and some crazy stuff on certain problems. But there was one exponent I never, ever used in that chapter. I couldn't. I never used -1. I don't know if you noticed it or not. Because when you go up by a power, that makes x to the 0, and you divide by the new power. Whoa. Dividing by 0? That's kind of frowned upon. Yeah. Can't do it. And so you would have been like, what's that make? So I just stayed away from it. But I knew that x to the negative first was 1 over x, or in this case 1 over u, and I knew that it was going to come out to be natural logs. So I had to hold off until chapter 5. I couldn't make this a -1. I could pick any other number I wanted to but -1. So now the whole truth has been laid out for you. Well, here's some trig, and it's a definite integral instead. I gave lower and upper limits of 0 and pi over 2, so this should be a numeric answer. Let's see if we can come up with it. When we do the u sub, it'd be better to make this the u. Now the question becomes, do we include the 2 in there? And I'd say, yeah, let's do it. It's not going to hurt. Because when we do the du, the derivative of the 2 is 0 anyway. And the derivative of negative sine of x will be minus cosine of x dx. All right, so I need a negative on the cos. I don't have a negative. I'll multiply by negative 1 to give myself that. I'll put another negative 1 out front to make up for it. This 2 is going to get booted to the front. It's going to be out here. All right, you can see that when we multiply these together, that'll be negative 2. We have a 1 over u now. And then everything else, the negative cos x dx, is du. Remember, you never ever want to mix x's and u's together when you integrate. That's just a recipe for disaster. But we're not going to have a disaster here. We're going to have a great answer of negative 2 natural log of u. Now, I was almost going to say plus c, but then I remembered, oh yeah, that's right. This is a definite integral. We definitely have limits of 0 and pi over 2. We've got to plug them in. Did you notice I didn't put the 0 and the pi over 2 over here? Because the 0 and the pi over 2 are x limits. I didn't want to mix them together with the u's. In fact, I need to change the u back to 2 minus sine of x before I put that pi over 2 and 0 on. That was bad form on my part. Let me redeem myself. There, that's better. And now that negative 2 can stay out front of the green brackets, or I can put it inside. I prefer always to keep it out front. I just think it makes it easier. All right, so that negative 2 is going to come down. And the pi over 2, the upper limit, gets to go first. Sine of pi over 2, that's sine of 90 degrees, that's 1. Natural log of 2 minus 1. That's the natural log of 1. Minus. Now the 0 gets to go in. Of course, sine of 0 is 0, so that's just going to be the natural log of 2. Since 1 and 2 are both positive numbers, I don't need the absolute value bars anymore. And so this will be the answer. It's not simplified yet. Natural log of 1 from algebra 2 is just 0. And so you have negative 2 times negative ln 2. That's going to be positive 2 ln 2. And by the way, 2 natural log of 2 is a perfect answer. If you don't know what you're doing and you just take the original problem and throw it into the calculator and get a decimal, I'm going to know that that's what you did. So, just be aware. All right. Hey, by the way, if you didn't realize that the natural log of 1 was 0, you can still be okay. There's a bunch of different ways to do this. I think it's kind of cool if I show you some of this stuff. If you didn't realize that this was 0, and you said, hey, natural log of 1 minus natural log of 2 would be natural log of 1/2, because that's okay to do that, and you still had the negative 2 in front, you could say the answer was that. Most textbooks won't write it that way, but it's okay. And the reason they won't write it that way is, well, let's face it, 2 ln 2 looks kind of nicer. There's no negative or fraction or parentheses, all of which are kind of irritating. What you can do to show that they're the same is this. Just use the power law backwards. Take the negative sign, bring it back up, put it here. Now it's not in front anymore. 1/2 to the negative first just flips upside down and makes it a 2, and it is the same answer. So again, don't be worried if everything's not working out quite the way you thought it was when you went to check your answer. You may still be doing the calculus the right way. So that's when you come see me or email me and let me know. All right, number 4. On this problem, we kind of have to get clever. I think I'll start out by making u 5x to the third. The reason I think that is I see that there's some squares over there, and I'm like, all right, we can kind of make this a little better. So u is 5x to the third. That means that du will be 15x squared dx. Okay, I'm going to kick the 9 out. It's no longer here. I'll give myself a times 15. I'll divide by 15 to make up for it. And the 15x squared dx becomes a du. This part of the problem becomes tangent of u. And 9 and 15 are both multiples of 3, so you can divide them both by 3 and simplify it down to 3/5 in front. All right, so that u sub made the problem look a little nicer. Now I just have to integrate tangent. A lot of people think, oh, secant squared. I'm like, that's the derivative. You have to take the integral. You're going the other way. They're like, oh, yeah, that's right. And the problem is there's no good integral for tangent. You know, the integral of cosine would just be sine. Integral of tangent, not so much. So speaking of sines and cosines, let's rewrite it. Instead of tangent of u, how about sine of u over cosine of u? All right, now at this point, we can do another u sub because sine and cosine are each other's derivatives. The only thing is I can't call it a u sub because I've already used the letter u, so I'll have to call it something else. I'll use w. W is literally two u's, double u. That's why it's called that. So w, I can either make it sine of u or cosine of u. I'm going to make it cosine of u. There's a reason for that. If I made w sine of u, then the derivative would be cosine of u, and I don't have a cosine. People are thinking, yeah, you do, you just circled it. I'm like, that's actually a secant. Oh. And so usually you want to make the denominator the letter. All right, so that's w. And so what's dw? Other than that whiny little aardvark girl from Arthur, dw is negative sine of u du. I don't know if you guys grew up watching that as well. My girls did. That was their age. All right. Okay, let's see what we have here. So the 3/5 is still in front. I still have not integrated this. I'm just changing the look of it. So I need a negative. -1, I'll put a -1 out here as a negative sign. So 3/5 is now negative. And the stuff I'm circling in green, negative sine of u du, is dw. Yeah. And the rest of it is just going to be 1 over w, because it's 1 over cosine. So I've got 1 over w dw. All right, now it's time to integrate. The integral of 1 over w dw is natural log of w. So our answer is going to be negative 3/5 natural log of w plus c. Oh, but wait a second. W wasn't in the original problem. W is actually cosine of u. But u isn't even in the original problem. U is actually 5x to the third. Okay. There we go. That is the answer. Ugh. You know what? U subs aren't going to work here. At least not right away, because if I made the numerator a u, then du would have a 3x squared in it. I don't have any squareds anywhere. And I can't give myself squareds. I can't give myself extra x's. If I made the denominator u, du would just be dx. I'd just be switching letters. I wouldn't be solving my problem. I'd just have something with a bunch of u's in it that would look equally as bad. So I can't do either one as a u right here. I'm sort of stuck. And the only way to get unstuck is long division with letters. Woo-hoo. Okay, so I'm going to write that out. Again, you can also do this via synthetic division if you put a -4 in the box. Just have to remember to put that 0 on the x squared term. I don't like synthetic division quite as well as long division with letters, just for a couple reasons that you're going to see later on as we progress through the year. So, but for now, either one works. Okay, this is a bit intimidating, so don't look at the whole thing. Only look at the first term of each one. And you say to yourself, x times what is x to the third? Well, x squared. So you put an x squared up top. And then like we've always done, you multiply. This time we have to distribute, so it's going to be x to the third plus 4x squared. If you had me before, you know my catchphrase, you know what I'm going to say. You have to draw the line and change the signs. Because even from a young age, you've always subtracted that number. Just that, your fourth grade teacher, third grade teacher, whatever it was, put a negative in front, nobody questioned it. I change all the signs and people question it. I'm like, I haven't done anything new. Besides, I need these to cancel, so one has to be positive, one has to be negative. All right, let's combine some like terms. Bring down the next one. But don't look at it. Just look at the first one only. In fact, really, you could bring down both if you want to. Since you have letters and numbers mixed, you can bring down as much as you want because you're not going to consider it right away anyway. All right, x times what is negative 4x squared? And the answer is minus 4x. So you put that up top in the quotient, bring it through using distributive again. That's going to be negative 4x squared for now, minus 16x. Draw the line, change both signs. And of course that's going to drop out, which is what we wanted. That's going to leave me with 7x plus 22. I could have just waited on that 22 and just dropped it all the way down. It didn't really matter. I'm not looking at it anyway. I'm just going to look at the 7x. X times what is 7x? Well, 7. Positive 7? Yeah. Okay, we'll put a plus then. Okay, cool. Distribute that 7 through. That'll give you 7x plus 28. Draw that line. Change those signs. It'll be a terrible cheer. That's going to leave you with negative 6 as a remainder. And so we go minus 6 over the divisor, which was the x plus 4. Well, that was fun. But why did I do it? Well, I had no choice. I was trying my very best to integrate this, and I was failing left and right. So instead, let me integrate something I can do. I'll take the quotient that I just found. I'll put it in instead of the problem I was trying. I mean, it is the same thing after all. And this is integratable. And that last term is going to turn into a natural log, which is why it's in chapter 5. All right, here's my final answer. 1/3 x to the third. Minus 2x squared. Plus 7x. And here comes the natural log. Minus 6. Natural log of x plus 4. Gotta have the absolute value. Plus c. Gotta have that as well. That's it. I didn't have to do a u sub because this was just a 1, so I was able just to be done with it. All right, so again, once in a while you have to use some pre-calc, some algebra 2 that maybe you weren't expecting to use, and suddenly there it is. All right, one more to go, and we'll be done with section 5 too. Good job, everybody, so far. Oh, this problem is so small and cute. I think I'm going to kick the 2 out, though. Put it up front. So what's the integral of secant of x dx? I mean, the derivative of secant is secant tangent, but we don't want a derivative, we want an antiderivative. And the problem here is you can't u sub it, because if you make u secant of x, there's not going to be a du around it. You can't give yourself x's, and you definitely can't give yourself trig. And to be honest, no offense, but I don't really think anybody in my class is going to really be able to kind of just think of how to do this off the top of your head. This is not an obvious one. As a student, I wasn't able to. I needed help. So we'll see what happens here, but give you a few minutes to mull it over, and I'm going to tell you how to do it. That is my job, after all. Okay, time's up. I'm going to tell you. You have to take this secant of x dx. I'm going to move the dx out of the way just for a moment. And you need to turn this into a fraction and multiply both the numerator and denominator by secant of x plus tangent of x over another secant of x plus tangent of x. Probably not one of my first 10 choices when I was trying to figure out how to do this as a student. Okay, why in the world would I want to do that? Well, here's why. If I do distributive property up top, I get secant squared of x plus secant x tan x. And now, believe it or not, I could do a u sub. Because the derivative of secant is secant tangent, and the derivative of tangent is secant squared. I've got everything I need. So I'm going to make the denominator the u. And like I just said, du will become secant x tangent of x plus secant squared of x dx, which is exactly what we have. So that green thing becomes the du. Remember, this got rewritten. We have 1 over u and a 2 out front. So the answer is going to be 2 natural log of u plus c. Remember that u is secant of x plus tangent of x, and don't forget your absolute value and your plus c. Good job.